Okay, so today we will learn linear dependence and independence of vectors. Linear dependence and independence. In your 12th standard, in the chapter application of vectors, you came across a relation. Say a bar is equal to lambda times b bar. So this kind of expression in one or two theorems you have seen. So can someone tell me what it was?
So scalar multiple.
Scalar multiple, two vectors are scalar multiple, then what happens?
Collinear vectors.
Collinear vectors.
So the vectors are collinear. It means that uh, their directions will be the same, and if you look at the magnitude, magnitude is just different for A bar and B bar. There was one more vector relation that any vector r bar in three-dimensional space can be written as x times a bar plus y times b bar plus z times c bar if a bar, b bar, c bar are non-collinear vectors. So this was also one of the theorem. So this a bar, b bar, c bar are non-collinear. Which will also imply that there are independent. So any vector in our R3 space, you have x-axis, you have y-axis, you have z-axis. So in three-dimensional space, any vector can be written as a unit vector in direction of x-axis is I that you denote, a unit vector in direction of y-axis that is j, and a unit vector in direction of z-axis that is k. So any vector can be written as ai cap plus bj cap plus ck cap. This we have already proved. Okay. So what do we mean by this? Okay. So overall, the problem is, or the thing that is very pretty much clear from this is in a three-dimensional space, only three vectors are enough to write any vector as a combination of those three. Like in this, r bar, any vector in R3 can be written as a combination of I, j, and k. This is the crux of everything. In three-dimensional space, three vectors are enough to generate any vector in that space. Similarly, in two-dimensional space, A times I cap plus B times J cap. Like in two-dimensional space, I mean to say that there is x-axis and y-axis. On a plane, any vector can be written as the combination of I and J. Okay, so this is what we are trying to understand. So no matter how many x's are there, so I can always write it down as the combination of two or three vectors. Okay, so what do we mean by dependence and independence? So for that, we will just write down what is n-dimensional vector first of all. N-dimensional vector is of the form vector as an ordered set. N-dimensional vector is an ordered set of n elements which is denoted by which is denoted by x1, x2 up to xn, or x1 to xn, where x1, x2 till xn are components of the vector. Look, even if this definition looks a bit, I mean, difficult to imagine or to visualize this, I will just take, say, x is equal to R2. I'll just write down example over here. So I am defining the space, say R2. What is R2? R cross R. The real numbers cross real numbers. What we mean by real numbers cross real numbers? So you have x-axis, which is all the, I mean, x-axis and y-axis there. Our x-axis is completely consisting of the real numbers on it. Y-axis consists of all the real numbers on it. And with the cross product of this two, you have seen as the cross product हमने 11th standard में देखा है, दो set का product होता है A cross B, A comma B, where A belongs to the first set and B belongs to the second set. So what do we get is a plane. Okay, and when you take any point on this plane, we know that it is a vector, and that will look like, say, 1 comma 1 is a vector in this. I can also write this as 1 comma 2. So this is two-dimensional space. So I will write it down here, two-dimensional space. Two-dimensional space, and this vector is two-dimensional vector. Two-dimensional vector. Okay. Then I can also make three-dimensional vector. Say I'll take the space, say R3, which is simply R cross R, which means that the space will have three axes: x-axis, y-axis, and z-axis, the three-dimensional space. So dimension means simply the number of axes that you can have. So this is x, y, z axis. When you take any point in the space, so for an example, I can have -1, 1, 2. The vector in this space can also be written as, say, 2, 3, -1. Horizontally, I mean to say, these two vectors are three-dimensional vectors. because they belong to three-dimensional space. And this space R3 is simply three-dimensional space. R3 is three-dimensional space. This is your second example. Now the problem is talking about the four-dimensional space. Can anyone tell me what is the four-dimensional space? What is four-dimensional space now? No one.
Sir, when we represent an time,
हाँ.
मतलब अगर हमने एक वेक्टर टाइम के बिहाफ पे रिप्रेजेंट किया तो वो
No,
फोर्थ।
no, 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 not that way. So you guys have been watching Interstellar and this kind of movies. Must have heard about five-dimensional space and this kind of things. So you have to try to understand. I mean, when I say three-dimensional, R is repeated three times. I mean, you're taking cross product of R, R, R. So when I take four-dimensional space, so that will be R cross R cross R cross R. So this is R raised to 4. R raised to 4, a vector in this will look like, say, 1, 2, 3, 4. This is four-dimensional space. So I can write this four-dimensional vector. It means that it has four entries. Okay.
Sir, how can we represent this?
You don't have a graphical representation for four-dimensional vector, five-dimensional vector. These are just study. I mean, theoretically, there is no graphical representation for four-dimensional or five-dimensional. Just like you said, when you are studying physics, say there are three components. I mean to say, okay, if you are talking about density at a point in a room, okay, so in a room, at some point, I want to check out the temperature, okay, and how I'm going to denote this. What I will do is I will give its points depending on its x-axis, y-axis, z-axis. So I will have some x coordinate for it, y coordinate and z coordinate. With that, now this is the location of the point, and since I'm studying temperature, what I'm going to do is at this point I will also give the fourth variable x1, y1, z1 and the temperature T. So this becomes a four-dimensional vector. But you cannot look at this graphically. I mean, that is not possible. Graphically, it is
Sir,
possible only for two and three dimension. Hmm.
excuse me, sir.
Hmm.
Sir, some of my friends are waiting outside. Can you let them in?
They should come on time, na? What is the time? It
Yes,
is
sir.
becoming 11 o'clock. And when I want to accept them, I have to stop teaching and come back here to accept their request.
Yes, sir.
Tell them to join in 2 minutes. Okay, fine. So we'll look at the definition of linear independence and dependence. So before we go for that, I'll write down linear combination. So a linear combination of vectors x1, x2 up to xn is given by c1 x1 c2 x2 plus up to cn xn, where c1 c2 to cn are constants. So what is a linear combination? Linear combination is simply this kind of expression. So I have n vectors. What do we mean by linear combination of n vectors? It is of the type c1 x1, c2 x2 up to cn xn. Say for an example, I have a first vector x1 as say 1 0 0, x2 as x2 as 0 1 0, and x3 as 0 0 1. Then linear combination is c1 times 1 0 0 plus c2 times 0 1 0 plus c3 times 0 0 1, where c1 c2 c3 are constants. Now my question is 1 2 3 a linear combination of x1 x2 x3? Take 2 minutes.
Yes, sir, it is.
Yes, sir.
Hello. Yeah. Shubham, can you tell me how?
So C1 will be 1, C2 will be 2, and C3 will be 3.
Uh, Please repeat.
So C1 is equal to 1,
Yes.
C2 is equal to 2,
Yes.
and C3 will be equal to 3.
Yes. So this vector 1, 2, 3 is the linear combination of 1, 0, 0, 0, 1, 0, 0, 0, 1.
Yes, sir.
Yes. So 1 into 1, 0, 0 plus 2 into 0, 1, 0 plus 3 into 0, 0, 1. So this is the meaning of linear combination. And depending on the meaning of linear combination, we define linear dependence and linear independence. So next definition, linearly dependent vectors. Linearly dependent vectors. Just a minute. Yes. So the definition is, so let x1, x2 up to xn be n vectors, be n vectors, then for the system C1 x1 plus C2 x2 plus up to Cn xn is equal to 0. Now we have infinitely many solutions. Infinitely many solutions. Then x1 comma x2 up to xn are linearly dependent. So if I want to check whether the vectors x1, x2 up to xn are linearly dependent, what we are going to do, I will start with this expression. C1 x1 plus C2 x2, C3 x3 up to Cn xn. I will equate it to zero vector. This is not just zero, this is a zero vector. And I will solve this. Okay. If I solve this and I get that there are infinitely many solutions to this, then what I will declare, those are linearly dependent. If it has a unique solution, what it will be? Can anyone tell me?
Independent.
Of course, independent, but what will be the solution?
A zero. All are zero.
Yes, C1, C2 up to Cn, all of them are zero. Can you give me a minute? I'm so sorry that I'm leaving again and again. Okay, so if the system has infinitely many solutions, then the vectors are linearly dependent. Now, linearly independent. Independent vectors. If the system C1 x1 plus C2 x2 plus up to Cn xn is equal to 0 has a unique solution, has a unique solution, which solution will be, as someone said, C1 equal to 0, C2 equal to 0, C3 is equal to 0. I will put all the Ci's as 0. Unique solution, which is all the Ci's are 0. Then x1, x2 up to xn are linearly independent. So just make up a proper procedure to check whether a vector is linearly dependent or not. And the procedure is, say if x1, x2, x3 are given to us, so I'll take three vectors. Say x1 is 1 0 1, x2 is say 0 1 1, and x3 is 1 1 0. Okay, and I want to check whether the vectors are linearly dependent or independent. So what is our procedure? I'll take C1 into the first vector 1 0 1 plus C2 into the second vector 0 1 1 plus C3 into the third vector 1 1 0 and 0 0 0. As I said, 0 is a vector. So this expression I will consider and I will solve it. So I will multiply C1, C2, C3, and this will be C1 plus C3. Please check the calculations. C2 plus C3. The third one will be C1 plus C2. When you multiply C1, C2, C3 and add the three vectors, what we will get is this 0 0 0. Now I have a system of equation. Now I can solve this by writing augmented matrix, and whenever I solve it, I will get the value C1, C2, C3. And if I see that C1 is equal to 0, C2 is equal to 0, C3 is equal to 0, I will declare that vectors are independent. If it turns out that it is not equal to 0, here I am getting infinitely many solutions, then I will declare that vectors are dependent. So what do you mean by vectors are dependent? So why we are studying it separately? So for that, I will just try to explain you what will mean by vectors are dependent. C1 x1, C2 x2 plus Cn xn is equal to 0. What do we mean by vectors are dependent? It means that there will be what will mean by vectors are dependent? Anyone?
There will be infinite many solutions.
Infinitely many solutions. Moreover, sum of the Ci will be not equal to 0. Am I correct? So independent means all of them are 0. C1, C2, C3, Cn, all of them are 0. Independent means this. So dependent means at least one of them is not equal to 0. Okay. So dependent means at least one is not 0. At least one is not 0. So what I will consider is, if dependent if dependent, then C1 is not equal to 0. So if C1 is not equal to 0, then what I can do is I can send that C1 x1 on the other side, C2 x2, C3 x3 plus up to Cn xn is equal to minus C1 x1. So x1 will be equal to, so C1 not equal to 0 hai. It means that I can divide the other side by C1, and what I will get, minus C2 upon C1 x1 plus minus C3 upon C1 x2 plus up to minus Cn upon C1 xn. What has happened? What is your conclusion?
X1 can be expressed in terms of the others, like R bar equals A bar, lambda A bar plus mu B bar, like that.
Okay. So what we mean by dependence is, when I say x1, x2 up to xn, one of the vector can be expressed as the linear combination of the others. We saw that linear combination is constant into one vector plus constant into second vector up to constant into the last vector. Okay. So this is what it means. Okay, when the vectors are dependent, one of the vectors we will be able to express as the linear combination of the other vectors. So the question will be like this: you check whether the vectors are linearly dependent. If dependent, find the relation. Okay, and relation can be found out using our infinitely many solutions method. So I hope the complete thing is clear. So if you want, if you are writing the notes, you can write down the remark that if vectors are linearly dependent, then one vector can be expressed as linear combination of others. Okay, so we'll move towards the examples now. Example 1. Check whether the vectors following vectors are linearly dependent. If dependent, find the relation. If dependent, find the relation. First one, x1 is equal to 1, 0, 1, x2 is equal to 0, 1, 1, and x3 is equal to 1, 1, 0. So first step, consider c1 x1 plus c2 x2 plus c3 x3 is equal to 0. So in that, what we will have, c1 times the first vector 1, 0, 1 plus c2 times 0, 1, 1 plus c3 times 1, 1, 0. On the right hand side you have 0 vector, that is 0, 0, 0. If you multiply and add, what we will get is c1 plus c3. The second row will be c2 plus c3. Third one will be c1 plus c2. So as we can see, what we have here is a system of linear equation. Three equations, three unknowns are there, c1, c2, c3. So our augmented matrix here will be 1, 0, 1, 0, 1, 1, and 1, 1, 0. The right hand side is 0, 0, 0. The first operation that we will do is R3 minus R1. So what we get? 1, 0, 1, 0, 1, 1. The last one is 0, 1. The last one is 0 minus 1, minus 1. The right hand side is 0, 0, 0. Next operation, R3 minus R2. So what we get here is 1, 0, 1. The last column 0, 0, 1, 1. Last column 0. So 0, 1 minus 1, 0, minus 1, minus 1, minus 2, and this one is 0. So rank of A is equal to rank of augmented matrix is equal to 3, which is the number of variables, right? So unique solution, either you can rewrite or you can simply say that this is homogeneous. So the unique solution will be c1 equal to 0, c2 is equal to 0, c3 is equal to 0. So vectors are independent. Anyone having problem?
No, sir.
Fine, I can go to the next example now. Example number 2. 1, 2, 3, minus 1, minus 2, minus 3, and third one, minus 2, minus 4, minus 6. So vectors are dependent or independent? Anyone? Orally?
Sorry, dependent.
Dependent.
Dependency. Dependent.
Okay, so let's start finding out what is the relation. Can you define the relation? Why you're saying dependent?
C1 equal to minus C2. मतलब first one is equal to minus of second one.
C1 is a constant, X is a vector. So this is your X1,
X1
X2.
X1 is equal to minus X2.
x1 plus x3 is equal to
But
x2.
we need relation between X1, X2, X3.
x1 plus x3 is equal to x2.
X1 plus X3 is equal to X2.
x2.
Okay. So let's see whether we get it. So consider C1 X1 plus C2 X2 plus C3 X3 is equal to 0. Look, if this question is for MCQs, you can orally check out and you can give the answer. But if it is for 5 marks, you will have to follow the complete procedure that we are doing. So what we will have, C1 into 1, 2, 3, C2 into minus 1, minus 2, minus 3, and C3 is equal to minus 2, minus 4, minus 6. And the right hand side is 0, 0, 0. So if we multiply and add, we will have C1 minus C2 minus 2C3. The second will be 2C1 minus 2C2 minus 4C3. The third one will be 3C1 minus 3C2 minus 6C3 is equal to 0, 0, 0. So I'll write down the augmented matrix. Augmented matrix. What we have is 1 minus 1 minus 2, 2 minus 2 minus 4, 3 minus 3 minus 6. Vertical line 0, 0, 0. Let's do the calculations. R2 minus 2 times R1, R3 minus 3 times R1. So what do we get? 1 minus 1 minus 2. So 2 minus 2 0, minus 2 minus 2 into plus 2. This will become 0. Minus 4 minus plus 4 0. The third one will also be 0, I guess. So you have 0, 0, 0. So we have the, what you say, echelon form. Now the rank of A is equal to rank of augmented matrix is equal to 1, which is less than number of variables, 3, the number of variables. Number of variables. So 3 minus 1, 2 are free variables. So 3 minus 1 is equal to 2 free variables. Free variables. Let's rewrite the equation. C1 minus C2 minus 2C3 is equal to 0. So as I have 2 free variables, I can put C2 is equal to R, C3 is equal to S. So what we have, C1 is equal to R plus 2S. So what is our solution? C1 is equal to R plus 2S. C2 is equal to R C3 is equal to S. Can you tell me one solution out of this infinitely many?
One minus one one.
Hmm. R is minus 1, S
3,
is
1,
1.
1.
Okay, so what you're doing is you're putting R and S as something. Like you're putting R as 1, R as say minus 1, S is equal to 1. Then what do we get? C1 is equal to minus 1
One.
plus 2, 1. C2 is equal to minus 1. And C3 is equal to 1. Right? And if I put these values in our this expression, look at this expression. We started with this. So let's put these values there. So what we have is x1 minus x2 plus x3 is equal to 0, which means that x1 plus x3 is equal to x2. So this is the relation between the three vectors. One thing I forgot to write down, here you have to mention that vectors are dependent. Vectors are dependent. Once you identify that there are infinitely many solutions, you have to declare that the vectors are dependent. And then we do this complete procedure and we come to this relation. Please read it carefully. Clear? One example for you. I will give you 5 minutes to solve. Example number 3. I'll give you just the three vectors. X1 is equal to 3, 1 minus 4. X2 is equal to 2, 2 minus 3. And x3 is equal to 0 minus 4, 1. Please do it. Homework for you. You have to check whether the vectors are dependent, independent. If dependent, find the relation between them. So x1 is equal to 1, 2, 3. X2 is equal to 3 minus 2, 1. And x3 is equal to 1 minus 6 minus 5. Second one, x1 is equal to 2, 1 minus 1, 1. X2 is equal to 1, 2, 1 minus 1. And x3 is equal to 1, 1, 2, 1. These two are homework for you.
Sir,
Yes, you can speak.
sir, minus 2t, 3t,
Hmm.
and t,
Hmm.
and infinite solution.
Sir,
What is the relation? Tell me the relation.
Sir,
sir, x equals to 3, x2 equals to 2t, x3 equals to t, x2 equals to 2t, and um,
You don't
x1.
have to find the values of x.
sir, the relation was 3x2 plus x3 is equal to 2x1.
Yes. You have to find the relation. You are not supposed to find the values of x1, x2. And here you are doing that in terms of c1, x1, c2, x2, c3, x3. Your x1 is simply the vector. It is not something that you are finding out. है ना? So,
Yes, sir.
so make this clear. Fine. I'll download the attendance and then we'll stop.
So excuse me, sir. Can you please show